So hello, everyone. Welcome again to an exciting DesiCop webinar. This time we will be discussing ethics. So just a few housekeeping things before we get started with this exciting series. So first note is that this is in partnership with the topical group on data science. So please join us. You can join us on Slack. You can follow us on social media. And for the Q&A, we'll be using an app called Slido. We'll be posting that link in the chat several times so that you can get your questions answered. The other thing is that we take code of conduct very seriously here, and so I'll sort of sum it up with something from another group that I'm part of. Sort of be gentle, be hard on ideas, gentle on people, right? So if you have something where you disagree with somebody's ideas, that's fine, that's wonderful, but no personal attacks. And otherwise, we'll follow the standard APS code of conduct. So here's a brief overview of our game plan for today, where after this welcome, we'll launch right in with our distinguished panel. And so they'll give a brief presentation on their work and some of their thoughts with ethics. And then we'll save the Q&A till the end, where we'll have a combination of interactions between the panelists along with questions from the audience. But because you'll have a Slido link, just as soon as you think of a question, you'll be able to enter it then, so it won't escape from you. So with that, let me stop my sharing, and then we'll start with our first panelist. So our first panelist is Aishik Ghosh, where he's a researcher at UC Irvine and a fellow at LBNL, working at the intersection of artificial intelligence and fundamental physics. His research has direct impact on questions of AI bias, fairness, uncertainty quantification, and the statistical evaluation of AI models. He's been a strong advocate for including discussion on AI ethics and limitations of the quantitative methods in data science curriculum. As part of a network of AI experts, he has worked with the OECD to develop a framework to compare tools for trustworthy AI systems, and continues to work with them on policy related to science and AI. He's concerned about democratic accessibility of technological resources and the education required to equitably share the benefits of AI in our society. So with that, let's get started. Aishik.
Hi, thank you very much. So I hope you can see my screen. I'm going to get started. Before I start, I just want to put a disclaimer. Unfortunately, I got pretty sick yesterday, because of which maybe you can still hear it in my voice. I might be a bit, the delivery might be a bit slow or without as much energy, but I hope the content is still interesting to everyone. Right. So I'm very happy to be here. And let me try. Yeah. So first of all, I think it's great to have this kind of forum and talk about data science education for physics students. That is incredibly valuable, and I think a very important thing to have, especially with how quantitative everything in the world is getting now. This kind of like a physics education, we often say, is gives us a lot of transferable skills, and data science as well. It gives us a playing with these kind of problems gives us a ability to use statistical reasoning and visualization of data, exploration of the data, and it also gives you intuition for what kind of measures make more sense. I'm just giving a pathological example here of how if you have a likelihood which is multimodal and then you use a mean to describe it, it's not a representative quantity, and these kind of things, intuitions, I think useful even afterwards, if after doing an undergrad in physics somebody moves on to any other field in the industry or even in research. And also more and more, I think it's important to understand what machine learning is doing. It's a machine learning is like having applications all around us, and it's not something you can avoid. So there's a lot of mystery around machine learning, and it if the greater society has a slightly better understanding of what it can do and what is probably some kind of snake oil that people are selling, it would I think it would help us make decisions better. And yeah, when you want to learn about limitations and implications of these kind of statistical techniques and machine learning, this is directly related to ethics. And I'll talk later about how it's actually a two-way street. It's not just we do the data science and then we think about ethical implications in society, but like those kind of ideas come back all the way to pure physics research. I'll show you an example of that. So also, just for context, what is machine learning? These are generally algorithms that learn patterns from some training data. So you give it data and it learns patterns there, correlations, and then it uses what it has learned to make predictions on new data that you can give it. And typically you can use it for classification and try to classify things into good or bad. If you're for physics, it might be some data we want to keep versus not, or on the internet it might want to filter spam from real content. There's also regression, predict, and also generation. So what is generation? Like if you're in love with Impressionism, you definitely know this painting is Starry Nights by this guy called Van Gogh. But like recently, there's this AI that has been able to outpaint. So it's able to imagine or hallucinate what the rest of this, if Van Gogh were to paint it bigger, how he might have done it. And you can see that this painting is just one small piece of this much larger thing that looks almost seamless. This is created by machine learning model. These are fun things to look at, the capacity of machine learning these days. And before I talk about my opinions, let me tell you who I am. So I am a postdoctoral scholar who works primarily on physics, so machine learning for particle physics and astrophysics. And there is my experiment, the image on the right. And if you see the tiny red circle there, you can see the size of 2 human beings. So our experiment is kind of big. And this is actually placed in a ring, which is even bigger. And besides that, I work with the OECD on guidelines for trustworthy AI and the impact of AI in science. And I am concerned about AI ethics, and I would like to do something substantial and make a contribute in that direction as well. So yeah, at the Large Hadron Collider wave, we have the detector. What we do is we smash these particles together, and our detector is like a camera which takes this image of this like completely chaotic thing, and then we try to make sense of it with machine learning. And at this collider, we care deeply about biases and risks. So on the right, this is just an example of how if you apply some machine learning classifier, it often completely reshapes a distribution, and you don't want that. So it has a certain kind of bias, and then we find ways of removing that bias to make this sculpting that you see this back into this long falling distribution. And not just that, we make sure that our data, so we train our models on simulations, and the way we generate them is fully transparent, or we try to make them transparent and auditable, so you can go back and see how this sample was produced. We spend months after months on testing systematic biases on our machine learning models. Does it perform similarly on subsets of the data? Is there something we need to understand better? And also, will our model generalize on new data? So when we apply it on something from the collisions, are there differences between our simulations and collisions? Yeah, and we find almost all the time that our models are overconfident. That's just how the way we train neural networks traditionally, they learn to be overconfident. So we know that, and we calibrate for that. And this we also try to find out what the model is really learning. It's a hard problem, but we try our best to do all of this. And this is on just collision data, right? This doesn't affect anybody's life that directly. So when I was first invited to this multi-stakeholder conference on AI policy, I had quite a shocking experience. I was categorized as mission critical. So we were the people for whom the impact, the biases of AI are very important. So me, as a physicist, and also some people who are working on machine learning for controlling transport systems, and I agree there, it is critical because lives would be lost. But on the other side, I saw people deploying machine learning models that actually affect the society, and that was not categorized as critical, which I thought was really strange. Because that actually affects people, and it affects marginalized people disproportionately, women and people from minority communities. And just as an example, I'm sorry, there are software out there that claim to be able to predict whether somebody is a criminal or not. And I'm sorry, just give me a second. Yeah. Yeah, and these kind of these models are not made publicly available or auditable. So we in physics are actually doing a better job of that than models that actually affect society. And similarly, there was a machine learning model that used to screen job applications, and turns out it learned historical biases against women from the data. So all of this was quite surprising that these things are not tested as robustly sometimes. And that's why I feel all of this makes me believe that it's important for us as people who are studying physics or doing physics to also care about ethics. If we say that a physics education provides a strong foundation for jobs in diverse fields, and I believe this is true. And if that's the case, then our data science education should not just be about how to use some techniques for solving physics problems. You should have a holistic education of the ethical implications of the kind of models you're developing, and how things might go wrong. We know that statistical techniques and metrics often find their way from science to the social applications. And some of the time, assumptions that make sense while using these techniques in physics may break down in these applications. There's a famous example of predpol, which I think picks up a model originally from geology to to help the police, and it obviously violates the assumption that the data is collected in an equal manner. And so it has all kinds of biases in it. I also feel that physicists bear some responsibility for the technology we build. If there's a dual use possibility, we know what the kind of things we've built in the past. And now we're building fast inference technology, for example. So I think it's always important to keep that in mind. Also, we've seen that scientific jargon is sometimes used to justify biased algorithms when no one knows any better. I talked about how our machine learning models are overconfident, but this actually has been used in the justice system to say that, look, this person has like 90%, the model is 90% confident that this person is a criminal. So this kind of thing, if more domain experts were to talk about it, it would help the society understand the context better. There's also the problem that sometimes the best solution isn't a technological one, and by investing our all of our focus and energy on trying to come up with a better prediction system using machine learning, you're actually you're missing out that the solution is not in better predictions, but maybe investing in social systems and education opportunities for education and so on. And last but not at all the least, I think AI ethics is an active area of research and a growing area of research, and it's actually very exciting, and people should consider it as a career. But going back to this point of metrics, I think the more as we, there's a scientification of social issues, sometimes you tend to focus on the parts that you can actually quantify into metrics, and that means that the stuff you can't quantify, you start to ignore it. That's one danger. And the other is if you have a proxy metric which kind of tells you what you want but not exactly, it's dangerous to try to interpret it as the exact metric. And this is something that especially people with the physics or technical training are prone to doing. And I will give an example from my own field to demonstrate this. So in physics, we usually think we have exact statistical metrics for everything, but this is one exception where I'm not going to go into the physics, but this is a kind of bias we have in our experiments coming from some calculations. And so you see the diagram on the left. So think of the green dots and the red dot as our performances on different categories. And an unbiased technique would mean that all the dots lie on the same point. And since they're far away, that volume that they create, that's our uncertainty, that's our bias. And we've often thought, why don't we just use machine learning powered debiasing methods to reduce this? And what you want with that recommendation is the image in the middle. So you do debiasing, which means all these points shrink and come to the same place, and you reduce your bias. But what actually ends up happening is that since the uncertainty is actually not estimated, there's no way to calculate the full volume, so you estimate it by the distance between the Gen 1 and Gen 2, and when you try to shrink this proxy metric, you only shrink it in one dimension, which means you've only shrunk your estimate of the bias and not the true bias. So this is a clear case in physics of the kind of danger there is. And of course, in the social applications, unlike physics, it's a lot harder to show and prove these kind of situations, but they definitely exist. Now, a real case in society, this is an example. So the Netherlands government back in 2013 had deployed this model to detect welfare fraud by people who were receiving them. And the thing is, before this had been deployed, the cases were looked at individually by humans. And so there was a way to, if you feel that you've been judged as fraud by accident, then there was a way to bring it up. Whereas once the model was deployed, there was no recourse for people. And it turns out the model had wrongly accused 30,000 parents of welfare fraud. And it was because of some inaccurate data. And also it learned strange things like it was much more likely to say that someone's committing fraud if they had a dual nationality with Turkey or Morocco or Eastern Europe. And it took 6 full years to get rid of this system. I mean, so 6 years it harmed the most vulnerable people, the society. And the other thing to think about is even if these kind of prediction models that are accurate, is that enough, or do people deserve the right to an explanation? And this is something the EU and European countries are increasingly engaging with, particularly France has some laws about this. And I think people will talk about this more as machine learning gets deployed in these kind of situations. Then I'm going to touch upon misinformation. So I'm sure a lot of us have seen large language models that have become they've taken over Twitter basically. They talk like us. They're able to chat with us and make jokes, write poetry, and people are talking about how this could be a cheap way of getting a therapist for yourself, your AI therapist, or it can teach you programming, or all of these things. But if I mean, there are dangers here because you can clearly see that there are two fundamental problems. The data is trained on is from the internet, and we know the kind of content that's there on the internet, and so it's going to pick up on all of these biases from Reddit and so on. Also, the model itself is not trained to be factually correct, or it's trained to sound plausible. That's how it's built. So it produces confident sounding but factually inaccurate statements quite often. And again, it's in the sciences or in computer science, it's easier to quantify these things. That's why I'm giving an example in coding on the right. So this chat GPT, I think it was released a few days, maybe a weeks ago, and they had to ban it on Stack Overflow, which is one of the main computer programming. It's a website where you suggest solutions for somebody else's computer programming problems. And people tried to use this AI bot to propose solutions, and what they found was it proposed solutions so confidently that the humans thought it was a good solution, and it was only much later, like, only experts were able to notice the mistakes in this, and so they've banned these kind of submissions. But of course, if you try to use the same bot for social applications, you will see all kinds of problems, and it'll be even harder to quantify the problems. So to conclude, hopefully I'm not taking too much time. The discussions of the importance of ethics in data science education, it's really a two-way street. I think there's the ideas that are useful that come from ethics, and it's easy to demonstrate these things on physics or like scientific data. And that's why my talk focused on this, but you will see a lot more actual discussion of the impact on society in the upcoming talks by the other speakers. And yes, I'd just like to end with this thing. There was a philosopher in the early 1900s, Rabindranath Tagore, who back then talked about the machine, which has no flexibility to individuals. It dehumanizes people and forms this rigid system that people must follow, and it's justified by science. So he was talking about how we are becoming automatizing and making things rigid, and it's funny that he talked about it in 1917, because now we're doing it even more with machine learning, where there's a rush to automate things with technological solutions, and this is definitely going to entrench systemic problems into these unquestionable machines that don't offer explainability or flexibility or human in the loop. Well, unless we do something about it, and some people are doing something about it. And I think in the greater society also needs to be aware of which direction we need to be going. Yeah, thank you very much.
All right, thank you for an excellent presentation. I'm sure others have enjoyed it. Just as a reminder to everyone, please, put your questions, like in the Slido, and we will get to them. Don't worry. But for now, we'll move on to our next panelist, Savannah Thais, where she's a research scientist at Columbia University's Data Science Institute, where she focuses on machine learning. She is interested in complex system modeling and in understanding what types of information is measurable or modelable, and what impacts designing and performing measurements have on systems and society. This work is informed by her background in higher energy particle physics and incorporates traditional scientific experimental design components such as uncertainty quantification, experimental blinding, and decorrelation and debiasing methods. Her recent work is focused on geometric deep learning, methods to incorporate physics-based inductive biases into ML models, regulation of emerging technologies, social determinants of health, and community education. She is the founder and research director of Community Insight and Impact, a nonprofit that focuses on data-driven community needs assessments for vulnerable populations and effective resource allocation. She is passionate about the impacts of science and technology on society and is a strong advocate for improving access to scientific education and literacy, community-centered technology development, and equitable data practices. She was the ML knowledge convener for the CMS experiment from 2020 to 2022 and currently serves as the executive board of Women in Machine Learning and on the executive committee of the APS Group on Data Science. And she's also the founding editor of the Springer AI Ethics Journal. She received her PhD from Yale in 2019 and was a postdoc at Princeton until very recently. Savannah, good to see you, and we are looking forward to hearing what you have to tell us. And you're muted, Savannah. Okay.
Sorry, let me make my slides big again. Is it the right? Does it look right? Do I need to like swap the display?
We're still seeing your presenter view.
Okay. Okay.
Perfect.
Okay, awesome. Yeah, so right, William already said a lot of this, so I'll try to go over it quickly. But yeah, I'm like a research scientist, research faculty member in the Data Science Institute at Columbia. And I did a math and physics undergrad, and then my PhD in physics on ATLAS, the same experiment that Aishik just talked about. And then I did a postdoc focusing on like physics-informed machine learning, as well as AI ethics. And my current work, like was mentioned, focuses in several directions. So some physics-informed machine learning, some interpretability stuff, complex system modeling, specifically looking at mainly at public health and policy modeling. And then contextualizing machine learning systems and research and advocating for a really holistic approach to development that is proactive about thinking about a lot of the issues that Aishik mentioned, and that go into building a kind of ethical socio-technical system. And I'm happy to talk about like how I kind of made this transition from very pure physics into the AI ethics space later in the question part if people are interested. So in this short talk, I'm going to kind of introduce one of the projects that I've been working on that shows how we can take skills that we build in physics and bring them to other types of model building that are maybe more societally focused. And then I'm going to talk about like what happens or what can happen when we're not careful about how we do that. And then I'll talk quickly about like some things that I think is important for physicists in particular to know, and ways that we can perhaps try to avoid some of these mistakes, although it's certainly not exhaustive, that part of the talk, because this is 15 minutes. So yeah, like was mentioned, I founded a couple years ago this nonprofit research institute that looks at trying to understand, well, several different things, but originally our first project was focused on trying to understand different like resource needs in communities and what risks associated with COVID in particular, although we've like expanded much beyond that now, what sorts of risks different communities were particularly vulnerable to, so we could understand like which communities needed different types of interventions. So we first developed these metrics kind of informed by a lot of domain knowledge, working with different public health researchers, urban planning researchers, sociology researchers, all of these kind of things. And I think like, and then we did, as I'll show, a bunch of kind of model validation and impact assessment and things like that. And the reason I bring this up as an example is I think that like it's very similar in some ways to what we do in particle physics, in that we're trying to make valid, and I want to put the emphasis on like valid statistical inferences about things that we cannot directly observe or measure. So like Aishik was mentioning with the Atlas detector, we go through a lot of kind of layers of software and statistical processing to probe what is actually happening in those proton-proton collisions. And when we're trying to look at things like social systems, we also kind of go through levels of abstraction like that. So it's really important that we take some of these scientific principles, like incorporating domain knowledge, diverse types of like experts, model building. We think about data collection and cleaning, and model validation. So we've written 2 papers about these particular metrics, where we were looking to both to validate them, and to try to uncover like what this could mean for public policy in order to effectively address some of these risks that we found. And so this is like a very preliminary approach, and we're working on like more kind of nuanced projects now, but this was the kind of first few things that we've published. So for validation studies, what we did is define proxy outcomes that again are informed by domain knowledge for each of our metrics. So we basically said, okay, what statistical measure can we use that is like closest to economic risk under a public health crisis? And then you can build a model basically to try to predict that proxy outcome. This is really commonly done in kind of computational social science work. And then you can look at things like feature importance, and you can do the same kind of like model assessment that we do in physics, where we look at, we compare the kind of expert-driven metrics to, expert-driven variables to a wider set of variables. We try to understand what's driving the model in certain directions, what has the most predictive power, all of these kind of things. And then also like, what is your uncertainty on all of that, which, yeah, I won't get into too much, but it's very difficult in public health and social systems modeling. Then we also did some unsupervised studies where we looked at like clustering different, trying to understand similarities between communities by looking at their similarities based on the underlying variables, our social determinants of health, as well as developing like a longitudinal public health kind of history data set, and looking at how those different variables like fluctuated over time to try to understand how communities could build resilience to a shock effect like the pandemic. And we found some really interesting things. Like, I won't spend too much time talking about this because, this is a physics community. But we found some, really interesting insights, like the percentage. This is my favorite one. We basically found, and other people have looked at this as well, that the percentage of kids enrolled in free and reduced lunch is a super important metric for measuring at-risk people who are missed by most of the ways that we traditionally look at poverty in a lot of these kind of social systems modeling approaches. And we looked at kind of like different approaches to understanding the causal graph for why that might be the case, like what information is this variable capturing that is missed, and looking for kind of policy-driven explanations for that. And we found some other kind of like policy suggestions for how communities can build crisis resilience through different policy shifts, like investing in community college infrastructure, improving protections for part-time workers, increasing community infrastructure, things like that. So I want to emphasize before I kind of switch to the next topic that the approach that I take to doing all of this work is like that our models are potentially they can inform things, but they're not actually, they're never modeling the true like underlying system. We have uncertainty, we have approximations, we have proxies in all of this model building. And so it can perhaps give us insights that then we can discuss with experts, but I do not work on things that are fully automating any kind of decisions or predictions. And that's because of a lot of the reasons that I'm going to talk about now, which is that all of these models that we build, they don't exist in isolation, and they often can make mistakes. So I'm going to talk about I focus in my work on kind of like what I call holistic kind of approaches to model building on 6 different areas of AI ethics. So we can think about like data collection and storage practices, how we actually design the tasks and learning incentives that we build models for, bias and fairness, which and model robustness, which I won't really talk about here because I think Aishik did a great job of covering that. And then equity in system deployment and outcomes, and more like downstream and diffuse impacts. So this is kind of how I conceptualize it to myself. And I think that things like research, regulation, oversight, advocacy, all of these things like should touch on all of these different topics. And there are ways that we can start to like improve all of these different areas. So I'm going to show some examples of kind of what can go wrong when we don't think proactively and holistically about those points that I just mentioned when we're model building.
6 aspects of AI ethics.
So looking first at data collection, storage, and sharing. So this is basically a short list of examples of things that have gone very wrong in this space. So for instance, there's a great series from MIT Technology Review detailing what they call AI colonialism, but talking about how data label companies that are used by many tech companies in the West, in the US and other countries to build some of these large foundational models that we are all familiar with. So it explains how those data label companies can exploit workers and political strife in the global South to like maximize profit for this very essential part of the machine learning pipeline, but is not what we traditionally consider like research work. And so it's like not put on the same level. We can think about data sharing, data collection, like what you collect data for one purpose, are you able to use it for another purpose? So there was this very like kind of shocking example of the crisis text line recently that used user text conversation from people in crisis, and they shared that anonymized text data with a for-profit spinoff that they started that's designed to like improve customer service chatbots for other for-profit companies. So we can think about like, right, what can we do with the data once we have it, and should there be regulations or considerations on that? Data brokerage firms are a huge thing that really pool different aggregated sources of data about people, and they're sold kind of indiscriminately to different organizations who might use them for very problematic kind of surveillance methods. We have companies that require drivers and workers to submit to different kinds of biometric data tracking and surveillance to try to prevent things like unionization organizing. And we have even direct partnerships between tech companies and law enforcement organizations where, for instance, Ring like distributed their doorbell cameras or worked with police departments, police precincts to distribute doorbell cameras to the community and to incentivize getting them placed in neighborhoods. And then there's been recent reports that actually Ring will share recordings from cameras directly with law enforcement without the owner's consent. So lots of concerns about data collection, sharing, reprocessing, all of these kind of things. And we can also think about what are we asking our models to do? There's been a lot of work talking about newsfeed information serving, information curation algorithms are designed for attention and user retention. They're not, and so this can lead to downstream unintended behavior that perhaps a sociology or anthropology researcher could have predicted, but we don't talk to those people always when we're model building. So we get things like viral spread of misinformation, radicalization pipelines, information silos. We also have researchers and people pursuing learning goals that are not grounded in any kind of science, like predicting faces or sexual orientation from people's voices, or predicting trustworthiness from a video of someone. Then we can also think about like how these systems we build are used and deployed. So who is subjected to them, who are mistakes made on, and who gets the benefits of these systems. So for instance, like Rite Aid deployed facial recognition software in an effort to prevent shoplifting only in low income areas. So you might say, okay, well, yes, like maybe low income areas have higher crime rates, but we still have these questions of like, you know, who gets privacy? Is it a right that we should all share equally? Is it an economic privilege? Who's subjected to surveillance algorithms and things like that? And I don't want to make sure I'm not like taking up too much time, so I'll go quickly. And then we have more diffuse things like Aishik mentioned, you know, focusing on technological solutionism can pull resources away from other types of recourse or system design. For instance, if we focus on using like traffic surveillance to optimize routing and signaling so that we can move more cars more quickly through our current road systems, by doing that, are we de-incentivizing investment in public transit or other types of solutions? And there's, you know, other examples I have on here that I'm happy to talk more about how algorithmic tools have completely transformed industries, have created new classes of exploited workers, have morphed how cities work, who has access to housing, all of these different kinds of things that are maybe not the initial point of the model building, but are happening as a direct consequence. And then quickly, I'll just say like what I think we can do from within physics to address some of these issues. So this is a kind of guidelines that I put together for some of my students. As you're working on projects, I think it's super, super important to think about the context of what you're doing. So you can start doing this even in HEP research, which, you know, we might think is isolated from these concerns, but I think Aishik pointed out really well is not always actually isolated, even though we're just working on scientific modeling. But you can think about things like documentation and reproducibility for your data sets and your models. You can think about if this is helping us learn about how machine learning works on a fundamental level so that we can build better like debiasing or auditing tools, and what technology transfer might happen from what you're working on. And then if you're working on industry collaborations or side projects, of course, the concerns get even more complex. You can think about all of these data points, think about if there are other ways, more transparent or even non-technical solutions for the problem you're looking at. Where could bias come in? What guarantees can you give on model performance? And how are the things you're developing going to be deployed, and how will the benefits and harms be distributed? And then, you know, these are principled questions. So you really have to think about, okay, you've gone through this kind of list. Do these align with your personal code of ethics and kind of how you want technology to influence the world? And I think I've like talked for too long maybe already, so I'll kind of skip these last points, but I think treating machine learning and data scientifically is super important. Like I've kind of mentioned, we do model building in physics in a very kind of principled way. And we can maybe bring some of those principles over to other types of data science and machine learning model building. And we can perhaps also influence, well, maybe understand more about what machine learning is doing in the first place to build safer, more transparent practices in the future. And then I just want to end on this idea that these are not just technical and mathematical problems. And although we are like technical, scientific people, I think there's always other things we can do besides just these technical approaches, which are very important. But we can do things like literacy building, advocacy, leveraging our institutional and collective power with our communities to work against these power structures, and also contributing to like legislation design. You know, we are experts in these areas, so we can perhaps share that with legislators to develop more meaningful regulations. Yeah, so thank you. This is a slide that I always end with when I give this talk, and I think it's very true. These are really big responsibilities, and we should take that to heart. So thank you.
Thank you, Savannah, for a great talk. And just as a reminder to everyone, please post your questions in the Slido. We'll keep posting the link. But with that, we will move on to our last speaker. But just before introducing him, I'll also note that this will actually continue to 1:30. So don't worry, you will have a chance to, actually interact with the speakers and get your questions answered. So don't be too concerned about the time. So we have plenty of time left, another about 45 minutes. So with that, we'll move on to our last speaker, Ian René Solano-Kamaiko. So Ian is a PhD student in information science at Cornell University. His research is focused on building and evaluating computing technologies that aim to improve the lives of underserved and marginalized populations. In particular, he is interested in community and in-home healthcare, automation, and the future of work, as well as climate resilience. Prior to attending Cornell, he received his MS in computer science from NYU, and he's a member for the Center for Responsible AI. So Ian, looking forward to what you have to say. And again, everyone, right after Ian's presentation, then we'll launch right into panel discussion and addressing your questions.
Awesome. Thank you so much for that introduction. Hopefully you all can see my screen and also hear me. Cool. Great. So yeah, as mentioned, I'm Ian. I'm a PhD student at Cornell Tech, which is here in New York City on Roosevelt Island. Not a lot of people know that Cornell has a campus here. It's in the background of that picture. Pretty campus, small campus, kind of weird place. But I'm also a graduate fellow at the Center for Responsible AI at NYU. And before I get going here, I just want to say that given the nature of this talk, I'm going to start with the land acknowledgement. I think it's important for this kind of conversation around ethical data science. So I'll start by reading this and say, I'd like to acknowledge that I work at Cornell Tech, which occupies part of the unceded homeland of the Lenape people, and that Cornell University is located on the traditional homelands of the Cayuga Nation. I want to recognize the longstanding significance of these lands for these nations, past and present. It's important that we acknowledge the forcible dispossession of both the Lenape and Cayuga people, and to honor them as the original inhabitants of these lands, of which we are uninvited settlers. As we talk about ethics within data science, we'll see that throughout this conversation, technology is rooted in people and the decisions we make both as a society, as individuals. So therefore, I feel it's important to acknowledge our past injustices in the United States, and as well as their systemic nature. I'm actually going to move my screen over too. Hopefully that doesn't ruin the screen share. Did that ruin it? Maybe it does. All right. Anyways, so yeah, a little bit about me, as been already mentioned. So I'm a PhD student at Cornell. I work with Dr. Nicola Dell and Dr. Aditi Vashishta. I'll skip over the kind of intro since we already talked about it. I just want to give a quick shout out to Dr. Julia Stojanovic and Fala Arif Khan. They make some amazing comics, and they've made amazing coursework on responsible AI or ethical data science. And I would encourage you to check those out. Lastly, just a little bit about me is before getting into academia, I worked for a number of years as a software engineer. So actually this kind of AI ML is fairly new to me, but I have this long history in building software and systems. And so I kind of take that approach to a lot of this work. Right, so this is I'm going to convince you slide that I'm not a physicist. I didn't major in physics. As mentioned, my background is in computer science. So you see this a lot, right? Like AI is the future and the future is here, every internet article. So hopefully this is me convincing you that like physics majors, when you don't go into academia, it seems like, at least from what I've seen in software, you're being employed. as data scientists, as software engineers. And so I think this material is relevant from that alone, but also it does seem from the outside like a lot of these data science methods are being used in physics. And so that's my spiel to convince you that this is relevant. So a little bit like quick overview. I know we've kind of gone over this a few times now. So like, what is data science? Why now? It's data science is impacting and has the potential to impact every facet of our lives, right? And I think in particular, what we're seeing is that there's an unprecedented data collection capabilities. There's increase in computational power and access, and a mature field with broader societal acceptance, which are leading to these trends that are happening right now, where it's impacting every piece of our lives, right? From targeted advertisements to life-saving medicines, right? And here's a little comic, which I like, from Fala and Julia, where you can see at the bottom, it says, you know, where are all the women and people of color in this tech utopia? So that leads me to like, yeah, what could go wrong, right? And we've talked about this already. So let's cover really quickly some examples of bias in algorithms. First, and this was Aishik kind of like alluded to this, and this was mentioned. This tends to be the canonical example of bias in ML. And so this is an article by ProPublica on a commercial software tool called Compass, which automatically predicts some categories of future crime to assist in bail and sentencing decisions. And essentially what ProPublica found was that Blacks were almost twice as likely as whites to be labeled a high risk, but not actually reoffend. So this is, like I said, one of these canonical examples of bias in our system or in the real world. And this is, if I'm not mistaken, this is Broward County, Florida. I think this is at the bottom too. Yeah. Another example is within automated hiring, and I'll talk more about this later. This is kind of like finds its way into my work. But here, Amazon scraped this like this AI recruiting tool. Basically, in the article, they scrapped the tool because it showed bias against women. Technology companies tend to be more male dominated, right? Especially within technical roles. And basically the Amazon system taught itself that male candidates were preferable. It penalized resumes that included the word women's, such as like women's chess club or any types of like women's organizations. And actually there were two women's colleges that were also put down or whatever. So less considered. So, okay. So what is ethical data science? Savannah kind of like covered a lot of this. I'll just focus on fairness, accountability, and transparency, but obviously there's a lot of stuff going on here, like data profiling and cleaning, and integration with data protection and privacy, legal frameworks, and so on and so forth. But like I said, I'll focus mostly on fairness, accountability, and transparency. And in particular, I'll focus on explainable AI. So I like this definition from IBM. It's not perfect, but it suits the purpose of this presentation. So explainable AI is a set of processes and methods that allow human users to comprehend and trust the results and output created by machine learning algorithms. Explainable AI is used to describe an AI model, its expected impact and potential biases. It helps to characterize model accuracy, fairness, transparency, and outcomes in AI-powered decision-making. So this seems like a decent overview of where to start. In particular, I think about explainable AI in terms of like a holistic approach, and I wanted to highlight three kind of like critical junctures that had been put forth a long time ago now, 1996 by Battaya Freeman and Helen Nissenbaum. And these are pre-existing technical and emergent bias. And so I'll just read this to you a little bit here. So pre-existing bias exists independently and usually prior to the system. So this has its roots in society. So this may be data that is collected that we know, for instance, we live in a systemically unjust world, right? And so the data that may be collected may be biased in itself. And that's what pre-existing bias is capturing here. Technical bias is a bias that's introduced or exacerbated by the technical properties of the system. So this is the technical design of the system. So statistical bias in the model, and then emergent bias, which arises only in a context of use. Generally, this is kind of looked at as the system comes up with some output, and that output influences society, and as a result, that the societal changes feed back into the system and influence the system more. So I think these like three junctures are important to think about when we think about explainable AI. Then I wanted to talk a little bit about explainability and transparency within explainable AI. So there's a lot of different questions that ultimately we're asking when we're thinking about explainable AI. We're basically, in this diagram here, you see there's this, we're feeding user data, and a lot of times into like a black box model, and some decision is being output. And when we're exploring like this idea of explainable AI, we're asking questions like, well, first off, like, what are we explaining, and to who are we explaining, and like, why are we explaining? But we're also asking questions like, how well does the system work? Or why was a person misdiagnosed or not offered a discount or denied credit, right? As well as like, are these decisions discriminatory, or are they illegal? And here you'll see on the left-hand side is a nice chart of like all these different types of questions and ways to ask the questions, as well as the explainable AI methods that are applicable to kind of like interrogating these questions. And obviously in a 15-minute talk, we won't go over it all, but this is just to show you like this world of explainable AI is much larger than just simply what I'm talking about here. Yeah, and as I alluded to, like, why is this important? Well, it's important first off because we have laws in the United States, and they don't necessarily regulate all of AI, but they do regulate certain facets of things. So we have the Fair Housing Act, we have the Equal Credit Opportunity Act, we have Civil Rights Act, right? So these things say that like, oh, you can't have disparate impact or disparate treatment of certain groups or individuals based on like race or within hiring or something like that, right? And we also have legislation coming down the pike, both in North America and in the EU. Stuff like the EU AI Act attempts to apply transparency obligations proportionally within their predefined risk category, within a predefined risk categorization framework. So this directly like relies on explainable AI techniques and transparency techniques to kind of like enforce this type of regulation. And this is becoming more and more popular. The Biden administration in May 2021 came up with an executive order around informing around like IoT devices and consumer products and security capabilities. So a lot of this legislation and regulation is coming, especially in Europe, and hopefully we'll see more here in the United States. And some of my work is is advocating for that. So we'll look at a little bit of that later. One thing I did want to touch on, and I know this is a physics crowd, but in terms of like unpacking and opening up these black box models, there are some methods in doing so. And two most popular ones right now that I wanted to highlight were both SHAP and SAGE. They do slightly different things. So SHAP is looking at like local feature importance, so an individual example in the model, and trying to explain and show you the feature importance values. And then SAGE is thinking about global feature importance. So it's looking at the entire data set in the model. So here you can see on the left-hand side, it says SHAP answers the questions, how much does each feature contribute to an individual prediction? And SAGE answers the question, how much does the overall model depend on each feature overall? Right? So I just wanted to highlight that as some of the tools within explainable AI, and there's many, many more, including like counterfactuals and all sorts of stuff, as you could see in that previous chart. So a little bit about my research and what I've been up to. One is we've been working a lot, especially at NYU and the Center for Responsible AI, and on nutritional labels. This is highlighting like nutritional labels for recruiting and automated decision systems. But we've been looking at nutritional labels in algorithmic hiring more broadly as well. This is a heuristic that's been getting tossed around in the community for a few years now. In particular, we are trying to think of nutritional labels as a method for public disclosure that ultimately like influences policy change. And here is one example where we're looking at nutritional labels for LinkedIn Recruiter, and recruiters within hiring or in LinkedIn, they're given this ranked list and trying to provide them kind of like introspection as to like what is going on here. Recruiters already know and that they can't rely on the system, but they don't really understand why. And so this is something that we've been exploring. So nutritional labels, obviously, like they come from like your can of beans at the grocery store, and like why this is a paradigm that's being put forth is because they're short and simple and easy to comprehend. They're also actionable. We can take actionable insights on them. And there's a standardization. So that's why we've been advocating for nutritional labels. Another piece of work, which is a little bit more complicated to explain in the time frame, but there's been this paradigm put forth, especially within computer science and machine learning, this idea that the more complex models are, the more accurate they are, but the less explainable. And in particular, we're interested in for like high-risk decisions in public policy. And basically, we're exploring this paradigm. In this research, we basically said, well, okay, we hear this paradigm a lot, and there's been some papers, in particular, Cynthia Rudin had a paper that was essentially saying, like, stop using complex models, use simple interpretable models for high-risk decisions in public policy. And we took that and wanted to explore this further. Explore this trade-off, and we essentially found that explainability, it was not directly related to whether a model was black box or interpretable, and it's basically more nuanced than we previously thought. So we found that basically using like objectively measurable criteria as well as subjective criteria, there's a few influencing factors. So one is that there are weaknesses in intrinsic explainability of interpretable models. So when we're talking about interpretable models, we're talking about decision trees and linear regression models. And so you can think about like in a low depth decision tree that makes sense, but in a really deep decision tree, things start to become more complex, and those aren't just, it's just not inherently interpretable. It also matters like what is the root node of the decision tree and things like that. And also more information about a model sometimes confuses users. So this was some of our findings from this work. And then lastly, kind of wrapping up, I know I'm at time here. This is some new work that I've been doing at Cornell. We know AI and ML is coming to the global South. There's a lot of companies that are continuing to like invest time and energy and money into building tools for the global South. It's not quite there yet, but we know it's coming, and so we're fairly concerned about this. And basically, our motivating factor here was how can XAI tools help support community healthcare workers in the global South? And in kind of going through this whole narrative and thinking about my past work, I was really interested in thinking about explainable AI from a more holistic all the way through the entire system. And so that led us to some ideas around interactive visualization. So we think that like by integrating interactive visual affordances in risk prediction mobile application, community healthcare workers are able to better understand what the AI does and how to operate it. And so this is really interesting, and this was motivated by the fact that like these are really low resource communities. They're also folks with limited education, and so the idea that you're going to provide them some like SHAP diagram and be like, oh yeah, you can understand it, it's just not going to happen. Or even trying to communicate some idea of like what confidence means or what probabilities are. It's just not realistic. So thinking about, well, how can we think about explainability much more holistically? How can we think about what agency looks like in terms of like the individual and the community healthcare worker as experts in themselves, because these folks are experts and tend to not be looked at as such. So I'll end there. There's a couple takeaways that I want to leave you with, which are One is we need regulation, like point blank. The regulation hasn't kept up. And there's not enough regulation currently. Two, data science ethics courses should be required at universities. This is starting to happen. It happened at NYU while I was there. It should happen across the country and across the world, and we should increase data science or just like technical education more broadly. And Savannah kind of pointed to this as well, which is like as technical folks, we can also do our part in kind of like helping and volunteering and these kind of things to participate in some of these like educational initiatives. So in lieu of this kind of ties in, right? In lieu of cogent regulatory policy, technology professionals have an obligation to hold these systems accountable and the people that build them. Many of these problems are socio-technical. They can't be solved with technology alone. Some of the problems shouldn't involve technology, and it's our job to say no. And I think in particular, it's important as technical folks to say no. Unfortunately, the way it works is like we have the gravitas, we're the believable ones. So your voice matters. And then interdisciplinary collaboration is key. Teams should include collaborators from a variety of disciplines, backgrounds, and expertise. Most importantly, where possible, include end users, include those most affected by the systems. These are the people that are going to feel the brunt of these technical implementations, right? And incorporate codes of ethics, frameworks, and systems where applicable. So I'll leave you with that. Thank you so much for your time. And I left it on questions, but yeah, that's my email. Thank you.
All right, so thank you. And so with that, one sort of public service announcement, we'll be posting this on YouTube, and we'll ask all of the speakers if they're comfortable with us linking to their slides. So hopefully we'll have all that information for you soon, but let's leap into some discussion. So one of the questions that's come up in our Slido is, where would you guys include ethics in the physics curriculum? You know, like my background is I was actually in the engineering school for undergrad, and so we actually had this thing called like an ethics class that we actually had to learn, but that seems to be uncommon in physics. So, you know, like if you're at a general department, where would you actually include this kind of a discussion?
I guess I can start. So yeah, I think it's a hard question because we don't even really teach data science and machine learning in most physics curriculums right now. Like a lot of it is learned very like ad hoc through informal means. So I would say like my first, suggestion would be that we teach that class and that we have an ethics component of that class. I do think in general, like something that I would like to see is more of a like philosophy, history of science class included in physics curriculum. Honestly, at the undergrad level, but certainly at the graduate level. And I think we could touch on some of these themes here too, but that's like very uncommon. I mean, we had to take a research ethics class in grad school, and I think it was like we went to like 2-hour-long like lectures where they were like, don't make up data or plagiarize. So certainly a lot more that we need to add. But yeah, I would say in a data science / machine learning class and potentially in a like philosophy of science class.
And any other thoughts from our other panelists? Thanks, Savannah.
I completely agree with what Savannah is saying. So no, from me, there's nothing to add.
So I'll add an interesting question. So Amazon discovered this bias in their actual hiring algorithm. If I remember correctly, they're the ones that determined it internally. Now, it's bad that it was there at all, but to their credit, they actually found something. And I've talked with some other companies that have had concerns about their own, like algorithms when they're developing, like hiring ones and do some tests for biases. But what can we learn from this? Like in some sense, this is, like it's bad that it was there, but it's good that it was found, and there could be many other cases where it's there and hasn't been found. So what can we learn from sort of the Amazon example?
I can take that. I mean, I think one thing that's been put forth is that technical bias, or these kind of like bias systems, sometimes are easier to fix than societal problems. And so that's maybe a silver lining slightly here, is that some of these systems, if detected, there can be changes made. And we've seen that both where they've been internally detected and also externally putting pressure on folks and being like, look, this is a problem with your, I think of like Dr. Tim McKeever's paper on facial recognition, right? And finding this and then going, this is a problem with your system, and they did fix it ultimately. So, I mean, I think that's one part of it. But as you're mentioning, these are private companies, many of which are becoming public utilities, which we don't have access to what's going on, right? And so I think that we also need to advocate for insights into their systems, right? Like that's part of what we were doing within the algorithmic hiring stuff, is saying, look, if I'm a job seeker, my personal stance, I'm speaking for myself, is like, I feel like you have the right to know that you're being evaluated by an automated decision system. And on the flip side of that, especially in given a negative outcome, right? I don't get the job. I feel like you also have the right to know why you didn't get the job, right? And so you can maybe you can take corrective measures, but also because maybe the system's wrong. So I think that we need to advocate for that as a society, because the effects are pretty catastrophic, and they're compounding, right?
If I could just add, sorry. I think like, yeah, something else we should learn from this, that maybe was known before they built this as well, is that like any kind of bias, like your bias is going to be reflected, societal bias is going to be reflected in your data set if you don't proactively fix it first and like address it first. So like I think we should be doing all of this stuff before we even try to build these things, and hopefully that's a takeaway that would come out of something like this, although like it doesn't seem to have like totally gotten across as much as one would hope.
Yeah, sort of trying to correct for bad data after the fact is a difficult way to live. We'll put it like that. So there's been a lot of discussion, like in terms of like things that we shouldn't do, on the ethics side. But are there, do you have thoughts on things that we should be doing? People are looking sort of like,
I feel like I'm maybe talking too much, but I think, not to be like, oh, my work is the thing we should be doing, but I think looking at model building and that kind of machine learning as potentially an informative tool is something that I would say we at least could be doing without being like super directly harmful. So, I think like these methods do have great potential, right? And I think like we all probably believe that, or we wouldn't be working in machine learning now. But I think viewing it as an arbitrator and a standalone kind of thing is where we run into problems. So I think, yeah, things we should be doing is looking at, this idea of like all models are wrong, but some models are useful, right? So like looking at what can we learn from these things without allowing them to have absolute power over the decisions that we make. And then also, all of the things that Ian talked about of looking at explainability, at enabling people to have recourse. I think those are all worthwhile things to do.
Mm-hmm. And I'll bring up a question that touches on something that you brought up earlier, Savannah. which is generally what are the main algorithms to detect quote unquote technical bias in the ML models? And are there algorithms to detect pre-existing bias? So, like somebody gives you this data set, right? Like how do you tell that the data set is biased or flawed to begin with before you even begin your training?
I'm gonna say Aishik and Ian should talk about that because I think you guys work in debiasing like more than I do.
Yeah, I mean, I don't think there's one, but there are many ways you can look at it. So, in a real like data set that represents like people, you're not gonna. I don't think there's any algorithm that'll find all the biases, right? Because you need to know like the technology will only do what you ask it to do. But of course, you can. Ian talked about the explainable stuff, so you can find you can train a model and find what it's doing and correct for that fact. You can there are many ways that, yeah, you can do statistical tests on the output of the model. Already on the data itself, you could see like things that you expect to find, like historical sorry if it's historical data, that it's going to have certain kinds of biases like gender biases and biases against minorities and so on. Like these are easy to find. There will be biases that you will not think you will not know to find. And then so when we look at these examples like the Amazon one you talked about, I think like some of them, I think we should know to expect and fix for them. And then sure, there will be other ones that we didn't expect, and then I think then you fix it afterwards. But
yeah, and maybe like if you guys wanted to like had things that you think about later and you wanted to add it to this sort of web page for people to look at, maybe it would be useful to have sort of a resource for physicists on like, yeah, if you actually are getting into data that are affecting real people, then, like, how do you look for bias either within your data set or later, right? I mean, there's some thoughts on differential fairness, like there are thoughts in terms of like oversampling and undersampling, and these all come with, like various caveats, in terms of like how effective they may be. But, like, I don't know if there's like sort of a literature review or much less one that sort of is physicist accessible, but that might be something useful to resource.
Yeah, I could give you, I mean, really quickly too. I was trying to end with this slide, and then I was like, it's going to be too much time, too much work. But like, there are resources available. I think like searching for the magic bullet, kind of like as folks have alluded to, is problematic in its own self, right? Like, but there are great tools out there like FairLearn, Aquinas, like IBM has IBM 360 FairLearn or some crazy name like that, so you can look these up. Those exist, and you can expect things in terms of like disparate impact and disparate treatment and equality of opportunity, right? But like the methods, and a lot of these things come up in exploratory data analysis, right? But the underlying methods and the learning is what's important. And so like a lot of the research coming out of the Center for Responsible AI, some of it is exploring these ideas in terms, but also looking at them from philosophy standpoints, right? From looking at RALs and whatnot, and then trying to apply them to responsible AI or ethical data science. So and then there's a whole nother component, like we've been talking about, is that you don't know what you don't know, right? And that's the importance of involving like sociologists and anthropologists and other folks, right? Because for me, it's pretty clear, right? Like I'm from New York City, I understand zip codes and stuff. Like zip codes is a proxy for race here in New York City and in the United States. But maybe you're not from the United States and you're doing this work, and maybe you don't understand that, right? So how could you know, right? But this is like a lot of the time, it's not the issues. I mean, sometimes they are nefarious, right? But a lot of the time they aren't. They're mistakes that are happening, and they're mistakes that are happening because we don't have systems in place, and because we don't have the education in place, and these kind of like guardrails, right? So there's not, basically my answer is not one magic bullet. There are great tools, right?
I think there are, so like bigger companies are able to have access to like someone who's like who has expertise in this, like looking into the ethics aspect of it, right? But sometimes the smaller the startups and all, they don't have a dedicated person. I don't know if I guess they could have a consultant who can help them with all of this. That might be a good way forward.
Mhm. Yeah. And again, we've seen that, that the people like Katie O'Neill, right, do run consultancies that do this sort of thing. So another question, which is a little closer to home for us, so I'll combine two. So, we have generative AI, right? Some of you have mentioned, like say, for example, ChatGPT-3 and, like sort of it's banned from Slack. But I've started seeing discussions about what about its use for homework, right? Like should people be allowed to use an AI to help with their physics homework? Or, like on sort of the darker side, there have been any number of papers that have surfaced in Retraction Watch or other cases where the data was fraudulently generated, but incompetently so. And so, like, do we have to worry now that people will use generative models to generate fake data? Any thoughts?
It was we were actually talking about this in my journal club yesterday. I think, yes, we should worry. Like, I think people are already worrying. We've been talking about even before stable diffusion and these things. We were talking about deep fakes and yeah, I think it makes complete sense to be worried. We already have huge issues with misinformation spread. And if it's easier to generate that content and perhaps even easier to generate it effectively so that it spreads even better or it is more convincing. Aishik mentioned like there's this huge problem of hallucination in these generative models, particularly in large language models like ChatGPT, where they convincingly, spew out information that seems right, but is not completely right. I think these are all things that are very concerning. And we were actually talking yesterday about the education point because there's these Twitter threads that are like, oh well, I will generate my essay prompt and my grading rubric, and then the student will generate their essay with ChatGPT, and then so I think someone actually did this whole pipeline, and then he had like GPT-3 like grade the essay based on the rubric that ChatGPT generated and the essay that like ChatGPT wrote or something. So yeah, all concerning. And I think like again, like we've been talking about, like the solution to this is not purely technical. Like there are some things, people have talked about like deepfake detection or watermarking, and I think like OpenAI is actually working on some kind of like statistical watermarking thing for ChatGPT generated content. But we also want to think about like what other like roadblocks, what other barriers can we put in place so that we're not like destroying the education system, and we're not enabling more misinformation spread. And so again, I think it's like a holistic approach is needed: legislation, technical literacy development, all of these things.
Anyone else?
I think so there's this nice article, I forget the name, is these professors at Princeton, they talk about, so where is it actually useful, these things. It can be useful if it's writing pure fiction, then you don't need it to be factually correct. But then that's a problem if a student who's been asked to write something for English homework is using that. The other is if it's kind of like an autocomplete where you don't remember how to write some, so that we already use Stack Overflow or the website for this. You don't remember the code for almost anything. You find something there and you adapt it to your thing. So there you could, like, these models could generate something. So you could think of them as, when you think of them as autocomplete and like helping you, it may make some sense. But if it's there's some, yeah, Savannah's yeah, it's Irvine's paper. And yeah, but to be very honest, I think like the essay writing or like fictional essay writing, that this is it's really good at that, and I probably is going to be very hard to detect if a student has done that. So maybe evaluation methods will have to change a bit.
So we're drawing towards the end of our time. And so I think we'll close with one question with hopefully a short answer from each of you, which was, if there was one ethics principle or idea that you'd want physicists working in data science to know, what would it be?
Very hard question. But I would say valuing interdisciplinarity is one of the biggest steps we can take. And there's often perhaps a lot of ego in physics. And physics is very valuable and it's difficult, and all of these things are true. And there's lots of stuff that we don't know, and there are people who spend their entire careers and thinking about, these issues. There are fields that have been grappling with social inequality and even looking at technology through this lens for much longer than we have. So yeah, interdisciplinary liberal arts education, that's always my thing.
I'd say like science does not live in isolation. It lives in a society, and you need to keep that in mind. Everything you work on, you develop, what you don't work on, everything matters. Yeah.
I should have went first. They both stole mine. Oh man, that's rough. Yeah, I mean, I'll just piggyback the same. It's the same too. I don't think that there's any one thing. I mean, I'm not, like I said, I'm not a physics major either. But I find in computer science too, it's like we tend, at least my bias, right? Like, I want to build technical work. I want to build systems, et cetera, et cetera. And so I need to know that that's my bias and check that bias, and also know that like Aishik is saying, like technology doesn't exist in a void, right? Like we're building technology, especially within AI and ML, a lot of the times for human beings, right? And they have real world human consequences, and so we need to think holistically about how we build technology.
Okay. And on that note, I'd like to again thank all of our speakers for spending time with us today, and also thanks to the audience for coming in and asking some excellent questions. Let's see. So